Hello students, welcome back to the lecture series of vectors, and this is our lecture number 4, and in this lecture I am going to discuss about the NCERT exercise number 10.3. So let us begin the class. So you see the first question, find the angle between the two vectors a bar and b bar with magnitudes √3 and 2 respectively, having a dot b is equal to √6. So the solution in this way, you see solution number 1. First of all, you take let theta be the angle between the vectors. Let theta be the angle between the vectors a bar and b bar. So it is given in the question that therefore modulus of a bar, this is given as √3 in the question. You see modulus with magnitude. So then modulus of b, this is given 2 only, and second condition is given here, the dot product of these two vectors a bar dot b bar is equal to √6. Now what about a dot b? By definition it is modulus of a bar into modulus of b bar, then cos of theta is equal to √6, and mod a, it is given as √3 into mod b, it is given as 2 only, then cos theta is already here, is equal to √6. So it is 2 cos theta will be is equal to, this is √6 actually, √3 into √2, so √3 is cancelled, we have only √2 remaining there. And after this you see, you can find in this way, is implies cos theta, this is equal to 1 over √2. So therefore confirmly theta is cos theta is equal to, you can write cos of pi by 4, and removing cos from both sides we will get theta is equal to simply pi by 4, and that is the solution for the question. Now we come to the next question, the second one. You see similar type question, find the angle between the vectors angle between the vectors this one and this one. So first of all, you take a bar is equal to this and b bar is equal to this. I am taking that. So you just write the second question, answer of the second question. First of all, you take solution, second solution. First of all, you take let a bar is equal to, take the first vector, it is I cap minus 2j cap plus 3k cap, and b bar is equal to, you take, this is 3i cap minus 2j cap and plus k cap. These are the two vectors, and let theta be the angle between the vectors, be the angle between the vectors, Therefore a bar dot b bar, cos theta is equal to, you can write directly, we have the formula cos theta. What is this? It is equal to a bar dot b bar divided by modulus a bar and modulus b bar, and you can give a modulus sign in the numerator also for the acute angle. This modulus is for only acute angle, and after this you see, this is implies cos theta is there, is equal to mod of, what about a dot b? A dot b is 3 into 1 is 3, minus 2 into minus 2 is plus 4, then 1 into 3 is 3, this is a dot b, divided by mod A, simply root over of is 1 square plus 2 square plus 3 square. Simple, is 1 square plus 2 square plus 3 square into modulus of b dot b modulus of b bar, it is 3 square 2 square 1 square. So we write here also root over of 3 square plus 2 square plus 1 square, and then it will give us cos of theta is equal to numerator 7 10. It is modulus of 10 is simply 10 divided by 9 plus 4 13 plus 1 14, and here also 14. 14 into 14 is root 14 into root 14 is simply 14, and it is obviously 5 by 7, 5 by 7, and from here we can find theta is equal to, so this is implies theta, this is equal to simply cos inverse of 5 by 7. It is not a standard angle, so you have to leave the answer here. Now we take the next question. Find the projection of the vector I bar minus j bar on the vector this. And number 4 question is find the projection of the vector this one on the vector this one. So I am taking the number 4 question because 3 and 4 are similar type questions. So I am taking solution 4, solution of question number 4. So first of all, we take these two vectors as a bar and b bar. So let a bar is equal to, let a bar, this is equal to I cap plus 3j cap plus 7k cap. This is a bar, and b bar is equal to, you take this is 7i cap, then minus j cap, then plus 8k cap. These are the two vectors. So what is the projection of the first vector? The question of is projection of this vector on this vector. So therefore the projection, we write the language, therefore the projection of this first vector mean a bar, projection of a bar on the second vector mean b bar. And what was the formula for this? It was equal to, numerator is the dot product of the two vectors a dot b, and on which vector you are taking the projection is the denominator modulus of b, because we are taking the projection on b bar, so it is modulus b bar only. Then the dot product of a and b is 1 into 7 will be is equal to 7, then 3 into minus 1 is minus 3, then 7 into 8 plus 56, and divided by modulus of b bar mean root over, this is 7 square mean 49 plus 1 square is 1 plus 8 square is 64, 1 square is 1. Okay, so after this you see, so 56 plus 7, this is 60 only, 63 minus this 60, divided by this is 50, it is simply 64 plus 50, it is 64 plus 50 only, so it is 440. So we write just root over of 114, and this is the answer. Units, you should write units because it is a length, therefore 60 by root over 114 units. So let me take the next one. So that each of the three vectors, this one and this one, all of these are unit vectors, and also they are mutually perpendicular unit vectors. So first of all, what we have to do, unit vector mean the modulus of each of these two each of these vectors is equal to 1, all of the modulus is equal to 1. So first of all, you take the first vector as a, the second vector as b, and then the third one as c. You just take here, let A is equal to, you write in the answer, let A bar, this vector is equal to the first one, 1 by 7 into 2 I cap plus 3 j cap and plus 6 k cap. This is A bar. Then take the second vector, B bar is equal to 1 by 7 into 3 I cap, then minus 6 j cap, then plus 2 k cap, and then C bar is equal to, you take 1 over 7 whole into 6 I cap plus 2 j cap, then minus 3 k cap. So first of all you take just modulus of each of these vectors. Therefore mod of A bar is equal to 1 by 7 is remaining here into, it is root over of 2 square is 4, 3 square is 9, and 6 square is 36. So 36, 40, 49 means 7, and this is equal to 1 by 7 into 7 will be is equal to 1. Therefore A bar is a, right? So A bar is unit vector, is unit vector. In this way you can show that the vector B bar and the vector C bar are also unit vectors. So you can show similarly, but you are to write in the exam. Similarly, modulus B bar is equal to 1, modulus C bar, this is also is equal to 1. So therefore A bar, B bar, C bar are all unit vectors. Therefore A bar, B bar, C bar are all unit vectors, are all unit vectors. So this is your first part of the question. And the second one, it is asking for also show that they are mutually perpendicular unit vectors. Mutually perpendicular, to show two vectors are perpendicular, mutually perpendicular, just you have to show that the dot product of the vectors is equal to 0. So first you see what is the dot product of A and B. Again you write here, again A bar dot B bar. If we get the dot product of A and B is equal to 0, then we can conclude that the vector A bar and B bar, these two vectors, are perpendicular. So A dot B is equal to 1 by 7 into 1 by 7. This scalar part is directly multiplied here, it's simply 1 by 49. Then take the dot product of this part and this part. So 2 into 3 will give us 6. Then 3 into minus 6 is minus 18. Then 6 into 2 is just 12. So 12 plus 6 is 18, minus 18 is 0. Finally we get A dot B is equal to 0. In the similar way you can show also that B bar dot C bar is equal to again 1 by 49 in the similar way. Then 3 into 6, this 3 into 6 is 18. Then minus 6 into 2 is minus 12. Then 2 into minus 3 is minus 6. So it is again 18 minus 18 is equal to 0. And similarly C dot A, this is equal to 1 by 49 into 2 into 6 is 12. Then 3 into 2 is 6. Then 6 into minus 3 is minus 18, and this will also give us equal to 0. So therefore the vectors A bar, B bar, C bar are mutually perpendicular. Mutually perpendicular. Okay, so next I am taking a fresh question. So this is our question now. Find mod A and mod B if A plus B dot A minus B is equal to 8 and modulus A bar is equal to 8 into modulus of B bar. So it is very simple, 6 number solution. So first of all, you take the left hand side. It is a bar plus b bar whole dot a bar minus b bar. This is given as 8. Very simple. It is obviously a plus b into a minus b format. So simply this is mod a square minus mod b square. Simple. Sorry, it is not 0. It is equal to 8. But mod a is equal to given 8 b bar. Mod a is equal to 8 mod b. So it is mod a square will be is equal to 64 mod b square, then minus mod b bar square is equal to 8. So it is simply 63 mod b square is equal to 8, and so mod b is equal to 8 by 63 and the square root of this one. Mod b is equal to 8 by 63. And what about the second one? This is b bar is equal to this, therefore you can write, therefore I am writing here, therefore modulus a bar will be is equal to, it is 8 times, you see here it is 8 times modulus of b, so it is 8 times of root over 8 by 63. So this is the first answer and this is the second one. Now come to this question number 7. Just evaluate the product. Very simple, and I think you can solve. It is simply 6 a dot a mean a square, then 21 a dot b, then minus 10 b dot a. B dot a is obviously a dot b again, and minus 35 b square, and that will be the answer. So I think you can solve this problem. Now come to the number 8 question. Find the magnitude of the two vectors a bar and b bar. You have two vectors a bar and b bar. You are to find the magnitude having the same magnitudes, and both of these two vectors have magnitude equals. Both of the magnitude of these two vectors are equal, and such that the angle between them is 60 degree, and scalar product is given as 1 by 2. So we take this as solution of the 8 number question, number 8. So you write here in this way. First of all, since the modulus of these two vectors are to be equal, so let me take mod of a bar is equal to mod of b bar of equal modulus. It is given in the question. Say this is equal to p. P is a positive real number, and angle between them is 60. So also the angle between the vectors be theta. Say theta is. So therefore theta is equal to 60 degree. It is given in the question, and the dot product mean a bar dot b bar, this is equal to 1 by 2 only, and a bar dot b bar is simply mod a into mod of b into cos of theta. Theta means 60 degree. You can write directly here 60 degree is equal to 1 by 2, and mod a it is taken as p, mod b it is also p, and cos 60 is simply 1 by 2 is equal to 1 by 2, and 1 by 2 will cancel from both sides. So we have only p square is equal to 1, and which will give us p is equal to 1. Do not take plus minus 1 because p is the modulus of some vector and it cannot be negative. So after this you write, therefore modulus of a bar is equal to modulus of b bar of equal magnitude, and this is equal to 1, and so these two vectors are actually unit vectors because modulus are equal to 1. Then question number 9, find x if for a unit vector a this product is equal to 12. So unit vector mean modulus is equal to 1. So actually x bar minus a bar and x bar plus a bar will give us for this question it is actually mod x bar square and control Z and minus mod a bar square is equal to 12, but this is 1 only. So mod x bar is equal to 13. This is 1 because it is unit vector given in the question. So mod x bar square is equal to 13 and x bar is equal to root over 13 only. Okay, so you can solve this problem yourself. And now we take the next one. If a bar is equal to this, b bar is equal to this, and c bar is equal to this are such that a bar plus lambda b bar is perpendicular to c bar, then find the value of lambda. So first of all, for the question number 10, you first find the vector a bar plus lambda b bar. So you can directly write, we have a bar plus lambda b bar. This is equal to, a bar is this one, so I am writing that it is 2i cap plus 2j cap and plus 3k cap. This is a bar plus lambda b bar. What is b bar? B bar is minus I cap, then plus 2j cap, then plus k cap. This is a bar plus lambda b bar, and this vector is to be perpendicular to c bar. It is given in the question, are such that a bar plus lambda b bar, this is a bar plus lambda b bar, it is perpendicular to c bar. So since you write directly here, since a bar plus lambda b bar, this is perpendicular to c bar. So since these are two perpendicular vectors, therefore their dot product is equal to 0. Therefore a bar plus lambda b bar whole dot c bar, this is equal to 0, and which will give us a bar plus lambda b bar is already obtained here. So you write that one is implies a bar plus lambda b bar is 2i cap plus 2j cap plus 3k cap. This is the first part, then plus lambda into the second part is minus I cap plus 2j cap and plus k cap. This is a bar plus lambda b bar whole dot c bar, and c bar is given in the question. You see, c bar, this is given in the question. C bar is what? C bar is 3i plus j. So I am writing here 3i plus j. You see here, so whole dot 3i cap plus j cap is equal to 0. Now complete this dot product. So this dot this will give us 2 into 3 components of I, it is 6, then 2 into 1 component of j plus 2, 3 into component of k is absent here, so 0. This is the dot product of this vector, and then this one plus lambda remaining same because it is a scalar. Now dot product of this vector and this vector, and it is minus 1 into 3 is minus 3, then 2 into 1 is 2 only, k cap is absent in this vector, is equal to 0. And here 6 plus 2 is 8, and this is minus 1, so it is 8 minus lambda is equal to 0, and implies lambda is equal to 8 only. So that is the answer for the question. And for the question number 11, show that this is perpendicular to this for any two non-zero vectors a bar and b bar. So to show that this vector and this vector are perpendicular, you just take this term dot this term is equal to 0. You just prove this whole term dot this whole term is equal to 0. Just expand the dot product, but before that you should consider this mod A is actually A only. This mod B bar is only B, not a vector, it is a scalar number. Similarly, this is only A and this is only B. So here the vector part is only B bar, and here the vector part is only A bar, and here vector part is B bar and A bar, and these mod terms should be considered as scalar. So by considering that, you just complete the dot product, all the terms will get cancelled, and you will get this value is equal to 0, and which will show that the vectors are perpendicular to each other. So I think you can solve this question number 11. Now we go to the next one, number 12 question. One more question, very important question. If A dot A is equal to 0, A dot B is equal to 0, these two results are 0, then what we can conclude for the vector B bar? It's a very simple question actually. You see, if you have the dot product A bar dot A bar is equal to 0, so what is the conclusion of this? It will imply this vector A bar is equal to 0 or A bar perpendicular A bar, and this is not possible. This is not possible because same vector cannot be perpendicular to the same vector. So A bar dot A bar is equal to the 0 vector. And similarly for the second one, A bar dot B bar, this is equal to 0, mean either the vector A bar is equal to 0 vector, or the vector B bar is 0 vector, or these two vectors are perpendicular. Any one of these three conditions should be satisfied to get the dot product is equal to 0. Now both of these two equations, mean this equation and this equation, if both of these two equations is to be hold simultaneously, then we are to take just the common section. The solution of these two is A bar is equal to the 0 vector. But if A bar is equal to 0 vector, then the question is what is the conclusion about the vector B bar, so that these both equations are satisfied. So obviously we can say that B bar vector can be any vector. Whatever be the value of the vector B bar, you see A dot A is 0 and A dot B will also be equal to 0, because from these two equations the only solution is A bar is equal to 0, and therefore B can have take any value or any vector. So the answer will be B bar can be any vector. It can be any vector to satisfy both these two equations simultaneously. Again I am telling, these two equations will simultaneously hold if A bar is equal to 0, but when A bar is equal to 0, then B bar can be any vector, because if B bar is 0, then also dot product 0. If B bar is non-zero, then also it is equal to 0. So the answer will be B bar can any vector. Then question number 13, if A bar, B bar, C bar, these are three unit vectors such that A bar plus B bar plus C bar is equal to the vector 0 bar, what is the value of this A dot B, B dot C and C dot A? Simple question you see here. So we begin with this line, A bar plus B bar plus C bar is equal to 0 vector. So we start with that one. Before that you should remind that the vectors A bar, B bar, C bar are unit vectors. That means the modulus of these unit vectors is equal to 1, because they are unit vector. So we start with this one, solution number 13. So you write here 13 number solution, number 13. So we have mod of A bar equals to mod of B bar equals to mod of C bar, and these are unit vectors, so their modulus are equal to 1, and with that relation given, A bar plus B bar plus C bar, this is equal to the vector 0 bar, and this is 0 mean the modulus is also 0. That means mod of A bar plus B bar plus C bar is also 0. This is now scalar number. In the previous line it was a vector number, but after taking modulus it is now scalar number. Then we can take squares on both sides. So this is implies mod of A bar plus B bar plus C bar squares is equal to right hand side is 0 square is obviously 0 square 0, and this is obviously mod a, sorry not mod, it can be written a simple whole square term equal to 0. Then expand this whole square, and we know that this expansion will give mod a square plus mod b square, then plus mod c square, then plus 2 times of a bar dot b bar, do not write ab only, plus b dot c bar plus c dot a bar, and this result is equal to 0. But as we have in the previous line that the vectors are unit vector, and therefore all of these terms are equal to 1, so you write 1 plus 1 plus 1 plus 2 times of a dot b plus b dot c plus c dot a, and this terms is equal to 0, and which will give us 1 plus 1 is plus 1 is 3, will go to the right side is minus 3 by 2. So the answer will be a dot b plus b dot c plus c dot a is equal to simply minus 3 by 2. That is the answer for the question. So this is our next question, number 14. In this question it is given that if either of this vector a bar is equal to 0 or b bar is equal to 0, then obviously the dot product is equal to 0. This is obvious case, but the converse need not to be true. It is given in the question. Also we know the converse of this is actually not true, because a dot b may also be equal to 0 without being they are 0 vectors. If we take a and b are two perpendicular vectors, then also the dot product is 0. So here you are to establish this relation or this statement only by one example. So let me take two vectors such that they are non-zero and perpendicular, and the example can be taken in very simple way that say a bar is equal to, if I take a bar is equal to say I cap and b bar is equal to say j cap, and for these two vectors obviously they are non-zero vectors, unit vectors, and I cap j cap they are actually perpendicular unit vectors, and so here we must have a bar dot b bar is equal to 0. So this is the supporting statement of the given statement that the converse is not true. So you just write this example. Next you come to the question number 15. ABC, this is a triangle and its vertices are given here, and we are to find the angle between angle ABC. So before that I am taking a triangle here. So let me take a triangle, a very simple triangle is taking here. Say this is the triangle, this is the triangle. So its vertices are given in the question, so I am writing the vertices. This is the vertex A, say A vertex, and its coordinates is 1 2 3, and we have to write the position vector, and that is simply I cap plus 2 j cap and plus 3 k cap. This is the vertex A. Vertex B, its coordinate is given as minus 1 0 0, and so position vector is simply minus I cap only, because j cap and k cap are 0. And the vertex C, this is given 0 1 2, so it is simply j cap plus 2 k cap, because I cap component is 0. So these are the vertices, position vector of the vertices. Now we are asked to find the angle ABC, that means to measure this angle. Let me take this angle is equal to theta. So we should find theta, and obviously this angle theta is the angle between the vectors BA bar vector and BC bar vector. So therefore we just find BA bar vector and then BC bar vector. So here you write the question number 15 solution. This is the question number 15 solution. So here you write, here BA bar is equal to BA bar is equal to position vector of A minus position vector of B. This reverse order, position vector of A minus position vector of B. The position vector of A is this and B is this. So this part minus this part will give us I minus minus plus I is 2I cap. So I am writing here 2I cap, then 2J cap, so plus 2J cap, then plus 2K cap, not 2K cap, 3K cap, simply 3K cap. This is BA bar. Then you find BC bar. So this is BC bar, mean position vector of C minus position vector of B, and this minus this. So J is I cap is 0, so 0 minus minus plus I cap is simply I cap here. Then J cap minus 0 is J cap plus J cap, and 2K cap minus 0 is simply 2K cap plus 2. Okay, so these are the vectors BA bar and BC bar. Therefore angle between BA and BC are taking as theta. Therefore cos theta is equal to what? This cos theta will be is equal to, in the numerator it is the dot product of the vectors, mean BA dot BC. BA dot BC, we give a modulus sign for acute angle divided by modulus of BA. So we write modulus of BA and modulus of BC. Okay, so this is implies cos theta is remaining in the left hand side is equal to dot product of BA and BC. This is BA and this is BC. So 1 into 2 is 2 only. I'm writing 2. Then 2 into 1 is again 2. Then 3 into 2 is 6 only. Mod is there. Mod is there. And divided by modulus of BA bar, mean 2 square plus 2 square plus 3 square. So we write root over of 2 square is 4, then 2 square is 4, then plus 3 square is 9, into again root over of 1 square, 1 square, 2 square. So 1 square is 1, 1 square is again 1, and 2 square is 4 only. So what we will get here, you see here, this will be equal to, that is implies cos theta is equal to, it is 6 plus 4 10, and modulus of 10 is obviously 10, divided by 9 plus 4 13 plus 4 17. So it is root over 17 into 4 plus 1 plus 1 is root 6. And so this is implies theta will be is equal to cos inverse of, it is not a standard angle, so it is just 10 divided by, you can write under a single radical sign, 102. So this is the answer for the question. Okay, so we take the next question. Show that these 3 points are given here and they are collinear points. So before that, you just write the position vectors of this point. Solution: the position vectors of the points A, B, C are respectively what is A? Position vector of A is here I cap plus 2J cap plus 7K cap. So we write just I cap plus 2J cap plus 7K cap. This is position vector of A. Then position vector of B, this is 2I 6J plus 3K. So it is 2I cap plus 6J cap plus 3K cap. Then position vector of C is C of 3I cap plus 10J cap minus K cap. These are the position vector of the vertices. Sorry, not vertices, position vector of the points. So therefore you just find what is AB bar vector. Sorry, what is AB bar vector? The vector AB bar, this is equal to position vector of B minus position vector of A. So 2 minus 1 is 1 only, 6 minus 2 is 4 J cap, and 3 minus 7 is minus 4 K cap. And what about BC bar? This vector BC bar is equal to 3 minus 2 is I cap, then 10 minus 6 is plus 4 J cap, then minus k minus 3k is minus 4k. Yep, this one. So therefore we see here, therefore AB bar, you see, sincere observation here, AB bar is equal to 1 into, you see this one, is it not the vector BC bar? Again, yes, it is BC bar. Sometimes it may be similar with BC bar after taking common some numbers from here, but here no terms is common, but this vector and this vector are obviously equal, so there will be 1. In some cases there may be a number common, say 2 is common, then the remaining part may be equal to BC bar, so you should notice that one. AB bar is equal to 1 into BC bar, and it is of the form this one. You see, if you have A bar is equal to some lambda into B bar, then what is the conclusion? The conclusion is A bar collinear to B bar, or A bar is parallel to B bar. This was the conclusion of these types of relations. So here also it is lambda 1 here. So AB bar is equal to lambda into BC bar mean, you can say that therefore this AB bar and BC bar are collinear. So AB and BC are collinear mean like this. This is say AB and this is say BC. Sorry, this is say BC. They are collinear mean the points A, B and C are also collinear. So you can write in this way, therefore the points A, B, C are also collinear. So that is the solution of the question. Then we take the next one. Show that the vectors, these 3 vectors are given, form the vertices of a right angle triangle, and this types of problem is already solved in the previous chapter. So I think you can solve this problem yourself with the help of that problem done in the previous chapter. Then you come to the question number 18. If A bar is a non-zero vector of magnitude A and lambda is a non-zero scalar number, then what about lambda A bar if this is a unit vector? So since lambda A bar is to be unit vector, so we must have, you can write, we must have this modulus of lambda A bar is equal to 1, because this vector is to be a unit vector, and that is implies we can write this is modulus of lambda into modulus of A equals to 1. But modulus of lambda remaining same, it is unknown scalar number, and modulus of A bar it is given with modulus A, this is magnitude A. So we write simply A here is equal to 1, and from this relation we can say A is equal to 1 over modulus of lambda, and this is the option number D. So this is the solution of the question, and here we finish this class. In the next class I will discuss about the chapter cross product or vector product of 2 vectors, and there will be some properties of cross product as well. We have an important theory, vector area, named vector area. That is a very important topic in the next chapter. So till then, thank you very much.